Alright, number 11 tells me x plus 2 squared plus y plus 1 squared equals 5. It says convert each equation from rectangular to polar form. So I know x equals r times the cosine of theta. And we know that same thing from when we did vectors. Remember when we were doing vectors, we were looking at this vector and this magnitude. For the x value, we said x equals the magnitude of the vector times the cosine of theta. And the reason for that is this point right here where it ends up, the x is the cosine of theta and the y is the sine of theta. The distance is the magnitude, which is also the radius. So when we're doing this, we're going to use radius instead of magnitude. Our y is going to equal r times the sine of theta. So I'm going to plug those in. I'm going to go, this is the equation of a circle, by the way. So I'm going to go r cosine of theta plus 2 squared plus r sine of theta plus 1 squared equals r squared. We know what the radius is, so we don't have to put r squared because this is the equation of a circle. So I can just leave it as 5, and that's what I should do. I don't know why I didn't do that at first. I apologize. So I'm going to square this out. R cosine of theta times r cosine of theta is r squared cosine squared of theta plus r cosine of theta times 2, and then 2 times r cosine of theta is 4r cosine of theta plus 2 squared is 4. I'm going to do the same thing here, so I'm going to get r squared sine squared theta plus 2r sine of theta plus 1 equals 5. I'm going to combine these like terms, the 4 and the 1, and I'm also going to put my sine and my cosine next to each other. So I'm going to have r squared cosine squared of theta plus r squared sine squared of theta plus 4r cosine of theta plus 2r sine of theta plus 5 equals 5. So I can subtract 5 from both sides and those cancel out. But while I'm also doing that, I'm going to factor out an r squared here. And I'm going to say r squared times the cosine squared of theta plus the sine squared of theta plus 4r cosine of theta plus 2r sine of theta equals 0 because I subtracted 5 from both sides. The reason I factored this out is from our identities, from our Pythagorean identities. I know that the cosine squared of theta plus the sine squared of theta equals 1. So this is now just 1. For r cosine theta plus 2r sine theta equals 0. Notice that they all have an r in them. And the goal is to get it equal to r. But here I have r squared and here I have r. Since everything has an r in it, I can divide by r. When I do that, I get the radius plus 4 cosine of theta plus 2 sine of theta equals 0. 0 divided by r is still 0. So I want to get it equal to r, so I'm going to subtract both of these, and I'm going to get r equals negative 4 cosine of theta minus 2 sine of theta. And now it's in polar form. I know it took some time. Now we'll be able to speed it up on the next one. But the next one's totally different. So it tells me x equals y squared over 4. X I know is r cosine of theta. Y I know is r sine of theta. This is squared. This is over 4. I want to get it equal to r. So what I'm going to do first is I'm gonna square this, but I'm also going to multiply by 4. So I get 4r cosine of theta equals r squared sine squared of theta. I'm going to divide both sides by r. So I get 4 cosine of theta equals r sine squared of theta. I'm going to divide this over, so I'm going to get 4 cosine of theta divided by the sine squared of theta equals r. Could probably leave it like this, but do I want to do that? No, I'm going to separate it out. So I'm going to say this is 4 cosine of theta over sine of theta times 1 over the sine of theta equals r. So I don't want a squared term in there. So cosine over sine is the cotangent. So I have 4 cotangent of theta. 1 over the sine is the cosecant times the cosecant of theta equals r. And now it's in the right form. So that's 13. Going to 15. Okay, it's like the first one that we did. So that should clear it up a little bit. 15 x plus 2 squared plus y minus 1 squared equals 5. I'm going to try to go a little bit faster. So r cosine of theta plus 2 squared plus r sine of theta minus 1 squared equals 5. R squared cosine squared theta plus 4 r cosine of theta plus 4 plus r squared sine squared of theta minus 2 r sine of theta plus 1 equals 5. Plus 4 plus 1 equals 5. So I'm going to subtract 5 from both sides. I'm going to put these guys together. I'm going to factor out the r squared. So I'm going to have r squared times 1 again, because cosine squared plus sine squared. So I'm going to have r squared plus 4r cosine of theta minus 2r sine of theta equals 0. I'm going to divide everything by r. So r plus 4 cosine of theta minus 2 sine of theta equals 0. And I'm going to bring it over. R equals, I'm going to put this first because it's positive. 2 sine of theta minus 4 cosine of theta.